Hello and welcome to another GCSE revision video, and in this video we're going to be looking at how to sketch the graphs of the sine and cosine functions. Okay, so before we start sketching our graph we're going to need to create a table, and we want to do the graph of the sine and the cosine. So let's get our angle, which we can call x, and let's take our function, let's say sine x and cosine x. Okay, I'm not going to have space to put everything, so I'm going to try and keep the intervals equal. So let's say we do 30-degree intervals. So let's say this is 0 degrees, and we'll go up by 30, so that's 30, and then 60, and then 90 degrees, and 120, 150, 180, halfway there. So that would be 210 degrees. This is just 3 times table with a 0 added on. The next one will be 240 degrees. 270 degrees. 3/4 of the way there. So the next one will be 300 degrees, 330 degrees, and 360 degrees. Okay, so let's partition them off, hopefully reasonably neatly. Okay. I think I should have learned a lesson from Blue Peter and did one that I'd done earlier. Okay, so we've got our table. I'm just going to polish that off a little bit. There we go. Okay, so the first thing we need is to do our sines and cosines. Well, we know our unit circle by now. So the sine of 0, of course, is 0, and the cosine of 0 is 1. Now, the sine of 30 degrees, we remember we chopped our equilateral triangle in two, so the sine of 30 degrees is a half, and the cosine is √3/2. That's just the height of the half of the equilateral triangle. And remember, for 60 degrees, the sine and the cosines were just reversed, so this will be √3/2, and this will be a half. And then for 90 degrees, the line's just going straight up, so the sine is 1 and the cosine is 0. There's nothing along the x-axis, and it's all the way up the y-axis. Now for 120 degrees, remember that the sine of 120 degrees is the same as the sine of 180 degrees minus 60 degrees, which is the same as the sine of 60 degrees, which is just √3/2. And now the cosine, well, that was the cosine of 60 degrees, but it's negative because it's negative cosine. Sorry, the cosine of 180 degrees minus 60 degrees is the negative of the cosine of 60 degrees. So this is just negative a half. Now for 150 degrees then, the sine will be just positive a half, and the cosine will be negative root 3 over 2. And then for 180 degrees, our sine is back to 0, and our cosine is now negative 1. But if you'll notice, we're getting the same numbers repeating again. So once we got to 0, the negative a half on the cosine is the same as the negative a half we got just before the 0. So that 120 degrees had the same value as the 60 degrees, and the 150 degrees had the same value as the 30 degrees. But the sine just reversed on the cosine, didn't on the sine. So let's see this pattern repeating when we get up to 210 degrees. So the sine of 210 degrees is a half, only instead of being positive, it's going to be negative, because we've moved into quadrant 3. And the cosine is going to be negative root 3 over 2. Because we're still in quadrant 3, so we're negative along the x-axis, and this time we're negative along the y-axis as well. So both the sines and cosines are negative, but the values are just going back on ourselves. So if the cosine of 210 degrees is negative root 3 over 2, then we'll expect the cosine of 240 degrees to be the same as the cosine of 120 degrees, which is a negative a half. And of course the sine here, we've got negative a half for 210 degrees, so we're going to look at negative root 3 over 2 for the 240 degrees. And we can go on following the same pattern. 270 degrees, the sine is going to be negative 1 because it's pointing straight down, and the cosine is going to be 0 because it's in line with the x-axis, with the origin on the x-axis. There's no x component. So for 300 degrees, we're now into quadrant 4, so the sine is still negative, but the cosine is going to be positive. So this is going to be negative root 3 over 2. And the cosine this time is going to be positive a half. And for 330 degrees, we're looking at negative a half for the sine, and we're looking at positive root 3 over 2 for the cosine. And of course 360 degrees, we're looking at 0 on the sine and 1 on the cosine. And that's our table. Okay, so now we've got our table of values. Let's see if we can sketch this graph. So it looks like the y-axis is going to go from positive 1 to negative 1. So 1 is the highest value it's going to get, 0 will be in the middle, and negative 1 is the lowest value. So we can fill in the halfway mark and say this is a half, and this is negative a half. And then I'm in line with the 0. Okay, so we need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So, yeah, 12. Okay, so 3 times 4 is 12. So if I divide this into a half, so that's 2. And then into half again, that's 4. and then these into thirds. I think actually when we include the 0 we actually need 13. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, let's chop some of the bigger ones up. That's probably gone a bit too far now. Not exactly evenly spaced, but okay, close enough, especially for just a rough sketch. Let's pick a colour. Let's pick blue for our sign. Okay, oh, and we need to, actually, before I pick a colour, let's fill in these things. So this is 0 degrees, so this will be 30. 60, 90. These really should be evenly spaced. They're not at all evenly spaced. 120, 150, 180, halfway there. 210, 240, 270, 300, 330 and 360, and that's as far as we need to go. Okay, so we've got our axes. Let's start plotting. I'm going to choose blue, or something that looks blue anyway, for my sine. So the sine of 0 is just 0, and then the sine of 30 degrees is a half. So I'm just going to try and draw a nice little line there. And then the sine of 60 is root 3 over 2. Well, that's going to be bigger than a half and smaller than 1, because root 3 is bigger than 1 and smaller than 2. And I know that because 2 squared is 4. So this is going to come somewhere between the half and the 1. So at 60, that's somewhere between the half and the 1. So I'm going to put it closer to the 1 than the half and join that up. And then at 90 degrees we're looking at 1. And now at 120 degrees we're back to root 3 over 2. So that's somewhere around here. And then 150 degrees we're looking at a half again. And then 180 degrees we're back to 0. And then 210 degrees it's negative a half. (240 degrees we're at negative root 3 over 2. So we're smoothing out again as we get closer to negative 1. (270 degrees we're at negative 1. And then we're at 300 degrees at negative root 3 over 2 again. So just coming down a little bit. And then 330 degrees we're down to negative a half. looks nice. Okay, and then 360 degrees we're down to 0. So that's our sine. That's our sine x. So I'm going to write y equals sine x. I'm going to pick another colour. I'm going to pick something that looks vaguely red, and we can do our cosine. Now our cosine at 0 starts at 1, and then it goes down to root 3 over 2, which is not far from 1, so it probably looks something a bit like that. And then at 60 degrees the cosine is a half. Now a half is down here. So we're looking at something like that. And then at 90 degrees we're at 0. And then at 120 degrees we're at negative a half. And at 150 degrees we're at negative root 3 over 2. And at 180 degrees we're at negative 1. And then at 210 degrees we're negative root 3 over 2 again. And then at 240 degrees we're at negative a half. At 270 degrees we're back to 0. At 300 degrees we are at a half. Dear, that's not a very nice line. 330 degrees we're at root 3 over 2. And 360 degrees we're all the way back up to 1. Okay, and then we can write in y equals cos x. Okay, if you'd like to see a smoother representation of this curve, you could just type in y equals sine x, y equals cos x into Google, and you will see a very nice graph. This graph is centered in the middle, so it extends both in the positive and negative direction. And as you can tell, it goes from +1 to -1 on the y-axis, which is what we would expect. What we don't expect, though, is this x-axis. It goes sort of 2, 4, 6, 8. Now ours went from 0, and then the graph repeated every 360 degrees, but this graph seems to repeat every 6.28, whatever these units are. Well, the clue is 6.28 is 2 times 3.14, and 3.14 is pi, is an approximation of pi. 2 pi will tell us that we're dealing in radians. So this, even though it doesn't say what unit it's working in, it's actually working in radians. And if you want to convert from degrees to radians, 2 pi radians is the same as 360 degrees. So pi radians is 180 degrees. Other than that, this is just a slightly better drawn version of what we did. It's a smoother curve, but other than that, it's the same curve. It's called a sine wave. The sine function is called a periodic function because it repeats periodically, and that period, of course, being 2 pi radians or 360 degrees. And it repeats forever in both directions, both positive and negative directions. And that's pretty much all you need to know about the sine and cosine. Okay, I hope you found that interesting. If you did, don't forget to like, comment and subscribe. If you're taking your exams this year, I'd like to wish you all the best with your revision and all the best with your exams. And I look forward to seeing you in the next video.